Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on hyperbolas. Last time, we learned that a hyperbola has two foci. The difference between the distances of any point on the hyperbola to the foci is constant. In today's lesson, we will review the equations of different types of hyperbolas. We will also learn about asymptotes. Students, if you are ready, let us begin the lesson with an activity. A hyperbola has the equation x squared over 9 minus y squared over 16 equals 1. Draw the graph of this hyperbola, marking the points with coordinates plus or minus 3, on the x-axis and the coordinates 0 plus or minus 4 on the y-axis. Then draw a rectangle whose sides pass through the coordinate points and are parallel to the coordinate axes. Finally, draw diagonal lines through the rectangle. Go ahead, students. We will review your results when I return.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, everyone. How did you do? Your final drawing should appear like this graph. The diagonal lines that pass through the coordinates of the vertices are called asymptotes. If a point P on a curve moves farther and farther away from the origin, and the distance between P and some fixed line tends to 0, then the fixed line is called an asymptote to the curve. An asymptote never actually touches a hyperbola, but as x and y become infinite, the distance between the line and the curve tends to 0. The equation of an asymptote to a given hyperbola with a horizontal transverse axis in the line, y equals plus or minus b over a times x. The plus or minus indicates the ascending and descending diagonal lines of the asymptote. In the last lesson, you solved a problem involving a hyperbola with the equation x squared over 36 minus y squared over 81 equals 1. You named the center, the foci, and the vertices of this hyperbola. To find the equations of the asymptotes, we simply take the values of a and b, which are 6 and 9, and substitute them into the equation. So the equations of the asymptotes are y equals plus or minus 3 over 2 times x. If this hyperbola had a vertical transverse axis, the equation would be y equals plus or minus a over b times x. Let us try another activity, students. Sketch the hyperbola with the equation 4y squared minus 25x squared equals 100. Determine the equations of its asymptotes and the coordinates of its vertices and foci.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello, students. I hope you did not find this activity too difficult. To begin, the equation 4y squared minus 25x squared equals 100 is equivalent to 4y squared over 100 minus 25x squared over 100 equals 1. Therefore, the equation of the hyperbola is y squared over 25 minus x squared over 4 equals 1. This tells us that the center is at 0, 0. A equals 5 and B equals 2. The vertices of the hyperbola are v prime 0, negative 5 and v 0, 5. From the relation c squared equals a squared plus b squared equals 29, we get c equals the square root of 29. Thus, the foci are 0 plus or minus the square root of 29. Because the transverse axis of the hyperbola is vertical, the asymptotes are y equals plus or minus a over b times x. So, y equals plus or minus 5 over 2 times x. How did you do, students? I am sure that you will have many more opportunities to practice using these equations. If the center of a hyperbola is at hk and not 0, 0, then the asymptotes are also translated by h and k. The equation for an asymptote to a hyperbola whose transverse axis is horizontal and center is hk is as follows. Y minus k equals plus or minus b over a times x minus h. Students, based on what you have learned in this unit, can you write the equation for an asymptote to a hyperbola with center hk and a vertical transverse axis? Please take a moment to write your answer down.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. You have studied a great deal about the properties of conic sections, and I am confident that you are able to write this equation. An asymptote to a hyperbola with center HK and a vertical transverse axis is given by the equation y minus k equals plus or minus a over b times x minus h. Was this your answer? Well done, students. To review, you can study the table that is found on page 106 of your textbook. This table gives all the possible standard forms of equations of hyperbolas and their asymptotes. Today, we learned how to sketch a hyperbola and how to draw its asymptotes. We also learned that equations for the asymptotes of a given hyperbola vary depending on the direction of the transverse axis and the location of the hyperbola's center. That is all the time we have for today's lesson. Until next time, thank you, teacher. Thank you, students.